Hi. Before going to solve problems on moment of inertia, you need to keep in mind a few important things to solve the problems. Okay, you need to remember few formulae to find the moment of inertia, and you need to remember a few basic principles to be followed during solution of the problem. Okay, so there are three main things that you need to remember. Okay, the first thing is the formula to find the moment of inertia. Formulae to find the moment of inertia. Initially what we will do is we will draw the reference axis. Okay, I will take this horizontal reference axis as axis 1 1 and vertical reference axis as axis 2 2. So while solving the problems on centroid of the plane figures, we used to take it as x-axis and y-axis, reference x-axis and reference y-axis. But here in problems on moment of inertia, we will be taking reference axis, or we will be uh, denoting these reference axis as axis 1 and axis 2. Okay. So if G is the centroid of the plane figure, if G is the centroid of the plane figure, so we will be asked to find moment of inertia about x-axis and moment of inertia about the y-axis. Okay, we will be asked to find moment of inertia about x-axis and the moment of inertia about the y-axis. Okay, now to find moment of inertia about x-axis, okay, to find Ixx, okay, to find moment of inertia about x-axis, we will be using two formulae. In that, first formula is I11 is equal to sigma igx plus sigma ay square. The second formula is I11 is equal to Ixx plus a into y bar square. Okay, so we will be using these two formulae to find the Ixx, means moment of inertia about x-axis. Similarly, to find moment of inertia about y-axis, we will be using two formulae, that is I22. Okay, I22 represents moment of inertia about axis 2 is equal to sigma igy plus sigma ax square, and one more formula that we will be using is Iyy plus a into x bar square. Okay, using these two formulae we will be finding Iyy, and using first two formulae we will be finding Ixx. Okay, this is the first note on moment of inertia. Coming to the second note, see, for semicircle, let me mark the centroid for the semicircle. Here x-axis centroidal, y-axis centroidal, x-axis and centroidal, y-axis. Okay, see, for semicircle, remember the moment of inertia about an axis. Okay, moment of inertia about an axis which is parallel to the diameter is always 0.11 r to the power of 4. So in the first figure, x-axis is the axis which is parallel to the diameter. Therefore, Ixx is equal to 0.11 r to the power of 4. In the second figure, axis YY is the axis which is parallel to the diameter. So in this case, Iyy is equal to 0.11 r to the power of 4. And for the semicircle, moment of inertia about an axis which is perpendicular to the diameter is always pi r raised to 4 by 8. Okay. Therefore, in this case, axis YY is the axis which is perpendicular to the diameter. Therefore, moment of inertia about that particular axis is pi r raised to 4 divided by 8. And in the second figure, x-axis is the axis which is perpendicular to the diameter. Therefore, Ixx is equal to pi r raised to 4 by 8. So, okay, depending upon orientation of the semicircle, the formula will change. So, in the first figure, Ixx is equal to 0.11 r to the power of 4 and Iyy is equal to pi r raised to 4 by 8. In the second figure, okay, so the formula are reversed, correct? So depending upon the orientation, you need to apply the suitable formula, okay, while solving the problems. This is a second note to solve the problems on moment of inertia. Coming to the third note, very important note, note number 3. Okay, so if the figure is symmetric about any axis, let me draw a figure here. Okay, now let me mark the centroid of the whole figure G. Let me draw the centroidal axis as well. This is centroidal axis. Okay, the figure is symmetric about x-axis and it is also symmetric about y-axis, correct? Now I have drawn centroidal axis for the whole figure. Let me draw the centroidal axis for the individual components. For rectangle 1, this is centroidal x-axis and this is centroidal y-axis. For rectangle 2, centroidal x-axis, centroidal y-axis. Rectangle 3, centroidal x-axis, centroidal y-axis. Okay, now if the figure is symmetric about an axis, okay, if the figure is symmetric about an axis and the centroidal axis for the whole figure and the individual component are same, then Ixx is equal to sigma Igx or Iyy is equal to sigma Igy. Okay, so carefully observe the figure which are written here. You can see that centroidal y-axis for the whole figure, centroidal y-axis for individual figure are same. Means the centroidal y-axis for the whole figure and the individual centroidal y-axis are in line. Okay, they are coinciding. In this case, this formula is applicable. Iyy is equal to sigma Igy. Okay, coming to the symmetry about the x-axis, the figure is symmetric about the x-axis, but The centroidal x-axis for the whole figure and centroidal axis for x-axis for the individual components are different. In this case, this Ixx is equal to sigma Igx condition is not applicable. You cannot use this condition. Okay, this symmetry condition is applicable only when the centroidal axis of the whole figure and centroidal axis of the individual figure are same, means both are in line. Okay, so for this particular figure, centroidal y-axis for the whole figure and centroidal y-axis for the individual components are same, means they are in line. Therefore, Iyy is equal to sigma Igy. But when it comes to the symmetry about the x-axis, of course the figure is symmetric about x-axis, but centroidal x-axis for the individual components and centroidal axis for the whole figure are different. Okay, you cannot use the symmetry formula. You need to follow the conventional method, means using this formula. Okay, using these two formula, you need to find the Ixx value. Okay, now let me take one more example on the symmetry. Okay, now let me draw the centroidal axis for the whole figure. G is the capital G is the centroidal axis for the whole figure. This is centroidal x-axis. This is centroidal y-axis. Centroidal y-axis. Let me draw the centroidal axis for individual components. For rectangle 1, centroidal x-axis, centroidal y-axis. For rectangle 2, centroidal x-axis, centroidal y-axis. For rectangle 3, x-axis and the y-axis. Now, in this case, figure is symmetric about x-axis and centroidal x-axis for the whole figure and individual components are same. They are all in line. Okay, in this case, the condition Ixx, okay, the condition Ixx is equal to sigma Igx is applicable. Okay, and when it comes to the symmetry about y-axis, of course the figure is symmetric about the y-axis, but individual y-axis and y-axis of the whole figure, they are not in line, they are not coinciding. Therefore, Iyy is equal to sigma Igy is not applicable. You need to follow this conventional method. Okay, I will explain the detailed procedure of solving the problems in next coming videos. So using these two formula, we have to find the Iyy. Okay, we have to follow the conventional method. Okay, so therefore, if the figure is symmetric about x-axis and individual centroidal x-axis and centroidal x-axis of the whole figure, they are in line, then Ixx is equal to sigma Igx. And if the figure is symmetric about y-axis and centroidal y-axis of the whole figure and the individual components are same, then Iyy is equal to sigma Igy. Okay, if the figure is unsymmetric, okay, if the figure is unsymmetric and if the figure is symmetric about some particular axis and centroidal axis of the whole figure and individual components are different, then we have to follow the conventional method of solving, means using these formula we will be solving the problems. Okay, so this much you need to remember to solve the problems on moment of inertia. Okay, so in the next video we will start solving the problems. Okay, thank you.